Today we're going to start with function notation. And the first thing I want to do is I want to look at a function table. We have our input and our output. And we can think about those as x's and y's. But first let's just think about input and output. If I were to take and put a 2 into my function, it would give me a 4. So imagine I could also plug in a 5 and it spit out a 10. If I plugged in a 9, it would give me an 18, 11, and it would give me a 22. First question I have for you, this kind of goes back to what we've been talking about for the last few days. Is this a function? And the answer is yes, because the x's do not repeat. The other thing we can do is we can try to actually come up with a rule for this table. What is happening every time we put a number in? It gives us a new number. What is it doing to that number? If we look, 2, 4, 5, 10, 9, 18, 11, 22, it looks like it's multiplying by 2. So I'm going to say multiply by 2.
So we can actually start to guess what else won't follow that rule and what else will get completed. So I'm going to take the input of 50 and we'll plug it into a
function. In this case, we would get, well, we get twice that. 50 times 2 is 100. If we were to plug in 35, what would we get out? Well, we get 70. If our pattern's correct, then if we plug in a 123, we get 246. We're just multiplying by 2 each time. There is a more sophisticated way to write function rules, and it is called function notation. So, as we take a closer look at this, when we have f of x, we write a rule. So whenever we want to write a rule for a function, we say first f of x, where x is the input. And then we write whatever our rule is. Now, we try to use a rule in math terms. So we say, what is happening to our x? What is happening to our input? So the function notation for the table above, what we did was we multiplied by 2. So our rule would be f of x. So we just say f of x. That means there's my rule for a function. We take x and we multiply it by 2. So I'm going to say f of x equals 2 times x. Now, when we evaluate a function, if we have a rule and we want to know what output would I get for an input of 50, we can write that in function notation as f of 50. What we're saying is we're going to plug 50 in for the input, and we want to know what would happen. So what we can do is, since we replaced the x right there with a 50, we can go ahead and replace a 50 in parentheses for where the x was. So there was an x in that equation, and now there's a 50, because we're checking what output we would get for an input of 50. When you determine the value of the output, you are evaluating a function. Now, I get that question a lot. Some of my students will see it on a test or a quiz, and they'll just have a moment where they go, uh-oh, it says evaluate, and I don't even know what evaluate means. It just means we're going to plug in our input and get a new output. We're going to try it. We're going to use the same function. We've got f of x equals 2 times x, and we're going to plug in f of 35. f of 35 would be 2 times 35. And so if we were to evaluate that, we'd get 2 times 35 is 70. f of 0 means we're going to do 2 times 0. Notice I'm using parentheses every time. And when we do that, we get 0. We could do it with 26, 2 times 26. And this is a pretty simple equation, so every time we do it, we end up getting just double. We'd even do it with negative numbers, so we could do 2 times a negative 2, and that wouldn't shock you with negative 4, okay? So that's kind of the basics of how we evaluate a function. In function notation, if we see f of x, it doesn't mean f multiplied by x. It just means that's my rule for what I'm doing to my input. So we'll get another example that's just a little bit more complicated. For this next example, we have the function f of x equals 2x minus 5. So whatever we plug in for x, we're going to replace for x in the equation. So I'm going to, instead of writing 2x minus 5, I'm going to write 2 times 20 minus 5. I'm replacing the x with the number I'm evaluating for. And so I did that there on all three of them. We're going to go ahead and do the math real quick. We're going to use order of operations. We multiply, then subtract, and I end up with 40 minus 5, and so that's 35. So f of 20 equals 35. If I do f of negative 3, when I plug in negative 3, what do I get out? And I get negative 11, because those both end up being negative. And if I plug in 0, f of 0 is negative 5. Okay? A lot of people, again, have that moment on a quiz where they go, oh no, f times 0, I don't know what f is. But that's not saying f times 0, it's saying plug in 0 into the function where the x would be. Now, another way to think about functions is as a machine. So when you have a machine function, you have input, something you plug in. You have your function rule that tells you what you do to that, and then it spits out a new number. It serves as the rule. It performs the operation on the input that result in the output. For example, if I had the function x minus 8, f of x equals x minus 8, and I wanted to find out what f of 5 was, I would take that 5, plug it into my function, and that means I'm going to replace the x with a 5. 5 minus 8 is negative 3.
And so that tells me that the f of 5 equals negative 3. Another way we can think about
it is we could use it for more than one function. So that was just one step, but we're going to try to do the same thing that we just did with the machine, except this time instead of just x and 8, I'm going to do 2x minus 8. So we're going to do that today with more than one operation. So the first thing we need to know is which operation we're going to do first. Well, if we follow order of operations, that means we're going to do multiplication first. We're going to multiply by 2. And then secondly, we're going to subtract 8. So we're going to try using the function machine. You don't have to do this every time you're doing a problem. I just want to illustrate a little bit. So find f of 12 using the function machine. So we're going to write each of our rules. We're going to do 2 times our function. I'm going to actually put a blank there with parentheses to remind you that every time we do this, when we plug something in, we put parentheses around it. So f of 12 means we're going to plug in 12, and we're going to write 12 in for our variable. So 2 times 12. 2 times 12 is 24. And now for our second step, we're going to take that 24 and we're going to plug it into our other function. Our second step, 24 minus 8, and we get 16. Now I'm really showing you another way to think about functions. If that machine part was confusing to you, but you got what we did on the first page, do not freak out. The machine part was just another way to think about it. So if you've got it down, we're going to practice it real quick. We have our function rule. This time it's a f of x, or it's a g of x instead of an f of x. That doesn't change anything. The letter doesn't matter. A lot of times you'll see either g or f. And so you see in the next one we have an f. And it doesn't really make any difference what the letter is out front. The most common ones you'll see is f, g, and h. So let's try this one. It says we have a negative 4. And that just means we're going to plug in negative 4 into everywhere we have an x. So we have an x in 2 places. I want to remind you, every time you plug in, use parentheses. It's especially important when you have negative numbers. Okay? So that's x squared plus 4x minus 1. So we're going to go ahead and plug in negative 4 in for x in both places. So I'm going to write g of negative 4 equals negative 4 squared plus 4 times negative 4 minus 1. So I replaced both of my x's with it. And now I'm going to use my order of operations. And if I do that, negative 4 squared with parentheses ends up being 16. 4 plus negative 4 ends up being, or 4 times negative 4 ends up being minus 16. And then we have minus 4. Combine those together, and I end up with just g of negative 4 equals negative 4. Okay, so that one kind of happened weird. Let's look at the next one. Maybe this one will give us, maybe g of 8 gives us 8. Let's find out. So I'm going to plug in 8 in for both of them. So g of 8 equals 8 squared plus 4 times 8 minus 1. Now I'm going to work through my order of operations. 8 squared is 64 plus 4 times 8 is 32 minus 1. If I were to add those together, I get 64 plus 32 is 96 minus 1 is 95. So g to the g of 8 equals 95. Okay, so it didn't give me the same thing. Let's try g of negative 1. G of negative 1 equals, in parentheses, negative 1 squared plus 4 times negative 1 minus 1. If I go ahead and evaluate each of those, negative 1 squared is positive 1 plus a negative 4, so I'm going to do minus 4, minus 1. And so g of negative 1 equals negative 4 when I simplify that out. Now I did get negative 4 already. I got negative 4 twice. Is that okay? Yes. I am allowed to get the same number in repeat numbers on the range. G of 1, last one here, and we get 1 squared plus 4 times 1 minus 1. If I do my math here, I get g of 1 equals 4. Okay? Now, all I'm doing is I'm replacing my x's, and I make sure I use parentheses, and then I just do my order of operations and I simplify that expression. Evaluate means that we're going to end up with just a single number, so each time we end up with a number. Although sometimes we need to actually work backwards. So I'm going to do 4 more examples here. This time, what I'm doing differently is this time it doesn't say evaluate. What we're trying to do is determine x such that we want to know what x would you plug in to get that output. So this is actually the output. And I want to know what you'd have to plug into that equation to get 18. In order to do that, we can remember that 4x minus 2 is equal to f of x. So when I have f of x here, I'm going to go ahead and replace that. I'm going to substitute that in, and I'm going to rewrite this equation not with the f of x, but with the other half of that equation. Since f of x equals 4x minus 2, I can swap those out like it's no big deal. That's what the substitution property says. Now I've got just a 2-step equation that we can solve by adding 2 to both sides. And I get 4x equals 20. And I can divide by 4, and I get x equals 5. Okay, so we can do that again. This time we have f of x equal to 0. So again, I'm going to swap out the f of x for 4x minus 2. It's still equal to 0. I'm going to solve that by adding 2. Add 2. And I get 2 on that side, and I'm left with 4x. So I'm going to divide by 4, and I get x equals 2 over 4, which is going to simplify to 1/2. Okay. Now, I'm going to show you a trick here because I could just set up each of these equations, but you'll notice that I'm doing the same thing every time. So rather than just setting up these equations, I'm going to go ahead and reverse it. Okay? This is a little bit of a trick, so if this scares you, don't worry about it. You can just go ahead and substitute it out. But instead of substituting out, what I'm going to write, then I'm going to take my f of x, so I'm going to do this in kind of this scratch area over here. I'm going to take the f of x, which equals 4x minus 2. And I'm going to try to get the x by itself. So I'm going to add 2 to both sides because that's what I did in both of those equations. I'm going to add 2, add 2. And if I do that, I get f of x plus 2 equals 4x. And then I'm going to divide by 4. Divide by 4, divide by 4. And now I've got my equation. I'm going to do the symmetric property switch around. X equals f of x plus 2 divide by 4. Every time I'd solve this equation, I'd do the same 2 steps. I would add 2, and then I'd divide by 4. Add 2 and divide by 4. So I now have a rule to go backwards. I have a rule to do the inverse of this function. So instead of doing each equation, I can use my inverse rule to plug it in. So if we look at the next one, it says negative 2. If I were to plug in negative 2 for f of x, I would get negative 2 plus 2 is 0 divided by 4, and I get 0 for my answer. So I could create my own rule to determine what that x is. But you don't have to do that. I just want to give you a little preview. We will do that soon, and I expect to be able to do that someday. But for today, we can just take a look at it like we have. So I'm going to do this last one just like the first two. I'm going to take f of x, and I'm going to substitute that out for the 4x minus 2. And I'm going to solve that for x by adding 2 to both sides. That gives me 4x equals, I'm going to just make it 2.5. And then we can divide by 4. Divide by 4. So x equals 2.5 divided by 4. Boy, that's ugly. I wish I kept it as a fraction. But I'm going to go ahead and type that in. That'd be 1.25 divided by 2, so it's like, it's small. Somebody type this in your calculator for me. If you were to leave it as a fraction, it would make our life easier, because if I were to say instead of 2.5, add 2, and 2 is really 4 over 2 when we have common denominators, so we have 5 over 2. And if I were to divide that by 4, I'd divide it, and I get 5 over 8. Okay? Man, that's easier. So don't be afraid of fractions. Sometimes fractions are easier than the ugly, ugly decimals we get without them. Okay? Now, hopefully that sets you up to just evaluate functions. If you don't get that little trick we did on this part, okay, don't scare yourself with that. But there's 2 ways we're really going to do this. One, we're going to plug in a number for the variable, and we're going to do that with parentheses, and we're going to do that everywhere there's a variable. And then we're just going to kind of use order of operations to solve it. If we have to work backwards, we sometimes have to use that equation, set it up, and solve the equation like we did on these down here.